Hi everyone. My name is Lopresti, Ag Victoria, and today I will be talking about some work we've done looking at delayed cooling, or also known as preconditioning, to attempt to reduce storage disorders during cool storage in stone fruit. Some of you may have heard of delayed cooling or preconditioning. Over the years, there has been research done in this area, but we did things slightly differently to attempt to make it viable or a possibility to actually implement commercially. So we'll talk about that in a little while. So today we'll cover why preconditioning, why may it work in reducing storage disorders. It's also known as delayed cooling or stepwise cooling. It's all the same thing. It's basically a treatment directly after harvest where you're not fast cooling the fruit. You're putting a slow cooling step before cooling down to 0 to 2 degrees. So I'm going to use those terms interchangeably today. I'm going to look at how we ran our trials, what approach we took, then results for Majestic Pearl Nectarine and Polar Queen Peach from the trials we ran last season, and then how can we potentially implement this preconditioning treatment commercially, which may be of interest to some of the growers out there. So storage disorders are a problem, and over the life of the current service supply chains project, we've done a lot of trials and we've found a lot of issues to long-term cool storage. So many current varieties are susceptible. Standard practices in Australia is generally to cool immediately after harvest, which may actually increase the risk of storage disorders. The other issue is that sea freight into importing countries can take well over 3 weeks, and many of the cultivars we grow potentially don't have that kind of storage potential in them. And also this cooling and warming after harvest. So we cool the fruit quickly, then it warms up again for packing, then we cool it down again, and then if it goes to the freight forwarder for air freight, fumigation, it gets warmed up again. So it's traveling through this kill zone of between 3 and 8 degrees multiple times, which isn't good for the fruit. So preconditioning may in some ways also help solve that problem. And this figure I've got on the right here, this was Glenn Hale did an outturn assessment in China at last season. This is Flavor Pearl, a very good variety with good storage potential. And once he received the fruit 32 days, after 32 days of not sea freight, total from harvest to the end of sea freight, he ripened the fruit over 8 days, so day 33, 34 and onwards. And as you can see, there was no change in firmness and no change in maturity. So basically, this fruit had been damaged to the point where it didn't ripen at all. Now that's scary to think that can occur, fruit that's been sea freighted in a variety that's supposed to be quite a good performer storage-wise. There was no flesh browning, but it just didn't ripen, so it could be an indicator of a storage disorder there. So why preconditioning? Look, this is a bit technical. There's been a lot of work done but basically I like to think of it this way. Imagine, you're in a sauna. You're in a sauna at 35, 40 degrees, and then you step out into -2 degree environment. You're going to get a bit of a shock. But the human body is quite complex, and our physiology can adapt. Well, in a way, stone fruit can't. So when you harvest stone fruit, they immediately begin to ripen, we could say, or proteins and enzymes in the fruit are activated, which are related to producing ethylene, breaking down cell walls, so fruit softens, energy and metabolism. The issue is that if you immediately cool, these proteins and enzymes aren't activated, whereas during preconditioning, a warm phase after harvest, these proteins are partially activated. You put the fruit in cool storage, then these enzymes and proteins remain there, ripening is delayed, but immediate cooling, cool storage, there's low temperature stress. And then when you try to ripen the fruit out of cool storage, normal ripening occurs in the preconditioned fruit, but in the fast cooled fruit, the fruit's unable to ripen properly because these proteins and enzymes that are required were never activated. I mean, I'm simplifying it there, but that's basically the theory behind it. So looking at this, there's been quite a bit of work done overseas on preconditioning, but the issue is that with their approaches, obviously they didn't look at our varieties because a lot of the research is quite old. When they harvested the fruit for the trials, they based it on fruit firmness, not actual fruit maturity. And this is an issue because you can have quite a wide range of maturity at harvest when you pick the fruit. The firmness can be pretty much the same as measured. So firmness isn't generally a very good indicator of differences in physiological maturity. They generally use a single preconditioning temperature, usually 20 degrees. They only have a few storage periods and ripening periods during the trial. And if you want to measure mealiness via fruit, how juicy the fruit is, that usually you do what you measure using expressible juice, which basically is sampling a small part of each fruit to measure how juicy the fruit is, which may not be representative of the whole fruit. So in our trials, what we did a little bit differently was we obtained fruit that was very uniform in harvest maturity based on fruit ripeness rather than firmness using a DA meter. We had two preconditioning temperatures, 12 and 18 degrees, because we want to see that does preconditioning work at 12, because that's a temperature that is more likely to be commercially implemented than 18. We ran the trial similar to what a grower could potentially implement commercially, multiple cool storage and ripening periods, and we measured the juiciness of fruit on the whole fruit, not a small section, which I think is very important. And the two trials were Majestic, the cultivars we looked at were Majestic Pearl, white flesh nectarine, and Polar Queen from Shepparton, a white peach that's highly susceptible to storage disorders. And this is how we ran the trial. So from the left, we monitored maturity the first several weeks before commercial harvest, then went in, harvested the fruit on one day. Then we segregated the fruit into maturity classes and selected the middle class, which is we call the commercial onset maturity class. And that made up about 75% of the fruit we actually harvested. So it was quite representative of that harvest. Then we assigned the fruit randomly to free preconditioning temperatures for 48 hours, 2 degrees, 12 degrees, and 18 degrees. The 2 degrees we can call immediate cooling or standard commercial grower practice. So that's your standard cooling, fast cooling down to 2 degrees. After the 48 hours, we sorted the fruit into trays, assigned them to cool rooms at 2 degrees, and we had 4 cool rooms, 4 replicate cool rooms, and then weekly removals for quality assessment. At each weekly removal, we ripened the fruit for 3 days and 5 days at 18 degrees. And a few more notes here, because it's important to understand the methodology, because we tried to implement it in a way, as I said, that growers could potentially implement it. Fruit was harvested at 25 degrees and into preconditioning treatments at about 22 degrees. All fruit was cooled to preconditioning temperature within 7 hours of going into those temperatures. So pretty fast drop in temperature. The treatment was 48 hours, which included both the cooling from harvest temperature and the preconditioning. And then, as I said, fruit stored for up to 6 weeks at 2 degrees with weekly removals and then ripening. Okay, so that's the background. Oh, there's one more background, which is quality assessments. We did the standard quality assessments, fruit maturity, colour, flesh firmness, soluble solids, titratable acidity, flesh browning incidence and severity. And for Majestic Pearl, we measured the free juice using a technique I came up with using an olive press and a way of chopping up the fruit that was very consistent, and we used the whole fruit. And I was the only one that did the assessment for the juice, so that we only had one single assessor, so you minimise the errors if you use more than one assessor. So basic quality assessments. Okay, now let's talk about Majestic Pearl. Right, so the idea on the left here, the idea was that the fruit that went into each storage, or each removal period, and each treatment was the same maturity. You wanted to take that factor out of impacting on potential storage disorders. So have a look at the graph on the left. The fruit at harvest was assigned to all these different storage periods and treatments, and it's basically all the same maturity. So we actually managed to ensure that we had the same maturity across all the fruit, across the whole trial, which is really important. And this is true physiological maturity. The graph on the right is how the physiological maturity based on DA, on the DA value or DA meter, how that changed during storage and ripening. And as you can see, among the free treatments, preconditioning treatments 2, 12 and 18, there was very little difference in ripeness over the life of the experiment, which is good to see. So we can basically say that the fruit ripened similarly among the free preconditioning treatments. So just to demonstrate that physiologically the fruit was pretty much the same across the trial as the fruit during storage and then ripen among the free treatments. Now, a question that growers might ask is, well, you're holding the fruit at 18 degrees and 12 or 18 degrees for 2 days after harvest. Isn't that going to impact on fruit firmness during storage? Well, yes, it will. And this is the result we had from Majestic Pearl. So this is fruit directly out of cool storage at 2 degrees after 0, 7, 14, 21, 28, 35 days. This is flesh firmness and the free preconditioning treatments. And as you can see, yes, the fruit that was immediately cooled to 2 degrees remained a little bit firmer than preconditioned fruit at 12 and 18 degrees. But this difference wasn't, up to about 28 days of cool storage, wasn't particularly large. I mean, all fruit was above 5 kilos. So yes, fruit is a little bit softer, but commercially, I don't think will have a major impact. You know, after 35 days, you're getting a bit more softening as expected in the preconditioned fruit. But I mean, if we look at end of sea freight being 28 days, then there's, you know, not that much difference in fruit softening over that period. And then if you ripen the fruit 3 days after each storage period, there's basically very little difference in firmness. If you call 1.5 kilos of firmness the eating firmness, that dotted red line, well, all free treatments are basically eating firmness, you know, apart from ripening at day 0, 7-day storage and onwards. After 3 days of ripening, pretty much get down to eating quality after 3 days. So again, very little difference between treatments. So all this is good. It means that you can precondition it at that higher temperature of 12 or 18, and fruit softening isn't a major issue. Some may argue otherwise, but I don't think it is. The issue, of course, is chilling injury or flesh browning, and this is Majestic Pearl, 6 weeks at 2 degrees, which is on the left, and then, 6 weeks at 2 degrees, and then ripening at 18 degrees for 3 days, which is on the left, and then ripening for 5 days, which is on the right. And they're the different preconditioning treatments, up the top 2 degrees, and 12 degrees and 18. And I've actually marked with black dotted lines or circles what we would call chilling, injury and flesh browning. And as you can see, the 2 degree fruit in both cases has high severity and higher incidence of chilling injury. And if you go down to the 18, well, it appears to be less. And I'll show you the data it actually is. Averaged across all the fruit, it's actually significantly different. So that's visually what we tended to see. 6 weeks is a long time at 2 degrees, but the way that sea freight is operating at the moment, I mean, it's not out of the realms of possibility that the importer will have fruit that has been stored 5 weeks since harvest, 5 to 6 weeks. That's not outside the realms of possibility when you've got air freight taking 4 weeks. Sorry, sea freight taking 4 weeks, not air freight. Okay, so the data to back up our claim that preconditioning works. This is, so we saw no flesh browning up to 3 weeks of storage, but this data is here is 4, 5, 6 weeks of storage, and at each storage time, you've got ripening for 0 days directly out of storage, then 3 days and 5 days. So 4 weeks after 5 days of ripening, we see a little bit of flesh browning in the 2 degree, in the immediately called treatment. And as we move along to 5 and 6 weeks, as fruit ripens, you see a big difference in expression of flesh browning incidence. So that after, say, 6 weeks and 3 days of ripening, you've got 35% incidence in the fast cooled fruit, and then significantly lower flesh browning in the 12 degree and 8 degree preconditioning treated fruit. So there's a big and a statistically significant difference there, a clear advantage to preconditioning. And if we look at how severe the browning was, this last season the browning severity was quite low compared to other seasons that we've tested Majestic Pearl, where we've found much higher severity. But even with low severity, there is a difference in flesh browning severity, with preconditioning reducing it significantly, again, statistically significantly, as you can see, especially after 5 and 6 weeks and after ripening. So it's pretty clear, and it sort of agrees with older work on other varieties that preconditioning has an impact on reducing the risk of storage disorders. And now this is a little bit more complicated, but even measuring the amount of free juice expressed from fruits, I mean, there was a treatment effect. So preconditioned fruit generally were juicier at each storage period and after each ripening period. And I've just circled that red circle sort of highlights the fact, you're getting at 2 weeks and 3 weeks, you're getting juiciness of 35, 36% from the preconditioned fruit at 18, and significantly lower juiciness among fruit that would precondition at 2 degrees. And these first 3 weeks, there was no sign of flesh browning. So are we actually seeing flesh dryness or mealiness much earlier than flesh browning in this fruit at 3 weeks? Because the fruit that was fast cooled to 2 degrees, I mean, the juiciness is very low there. You're looking at 12%, and 24%, which is very low after 3 weeks and after ripening. So the juiciness, this measurement could be showing us that the fruit are drying out, the texture's changing, becoming mealy, but there's no sign of it in terms of flesh browning. But if we actually go to 4, 5, and 6 weeks of storage where there was flesh browning, we see a similar story where the preconditioned fruit is juicier at 5 weeks and 6 weeks. The pattern's the same. At 6 weeks, juiciness is reducing in all the treatments because the fruit's basically gone beyond its storage potential. But at week 4 and 5, it's clear that preconditioned fruit are juicier. And we need to remember that you might ask yourself, well, the preconditioned fruit is probably softer and riper. No, it's not. The ripeness of fruit among each treatment is exactly the same as I showed before. So this is fruit that's of similar ripeness, yet the preconditioned fruit is juicier. So important finding, I think. Okay, so Majestic Pearl preliminary findings. Preconditioning seems to reduce storage disorder incidence and severity beyond 3 weeks. Preconditioned fruit appears to be juicier, or we could say less mealy, at a similar ripeness during storage and ripening. We did find that there was similar fruit maturity ripeness among all the treatments at each removal, which is a good sign. It means that preconditioning at high temperatures isn't speeding up the actual physiological ripeness of the fruit, which we don't want. Preconditioned fruit softens marginally faster during extended storage, but it's unlikely. This marginally faster softening won't necessarily have an impact on commercial export storage potential. And we did find a lower disorder incidence and severity than previous years, and that could be down to a number of factors, which I probably won't discuss here, but I mean, we harvested this fruit from Cobram, which is a cooler climate, versus warmer climate fruit that we've used in other seasons. Harvest maturity could be an issue, which we couldn't look at. We did look at, but I'm not going to discuss here. So there are other factors. I'm going to go through Polar Queen. We didn't do fruit juiciness with Polar Queen because I ran out of time, but the data is pretty much similar and the results are similar. So again, Polar Queen maturity at harvest was the same across all fruit that we assigned to different preconditioning temperatures and storage periods. And then on the right-hand side, you see how the fruit ripened over the storage period. That shouldn't be 1 to 6 days. That should be 7, 14, 21, 28, and 35 days. My apologies. Forgot to change that. But as you can see, pretty much the same ripeness at each removal as we saw for Majestic Pearl. In terms of fruit firmness after storage with no ripening during this 5-week storage period, again, no difference in fruit firmness among the conditioning treatments. So preconditioning basically had very little impact on fruit softening relative to fast cooling or medium cooling. Again, a good sign. And a surprising sign, I guess, in a sense, but that's the result. This is, now if you look at this and it looks a bit strange, that's because it is. So on the left is the fruit firmness after ripening for 3 days at 18 degrees. So after no storage or 7 days storage, the fruit ripened down to, down to one kilo, which you expect after 3 days, 18. But as the storage period increased, the fruit firmness after ripening actually increased, and it happened at 5 days of ripening as well. Now that's a little bit weird. It should remain well below 2 kilos after 3 days of ripening. So what's obviously happening is this fruit's been damaged, and its storage potential, this is a white peach, is very short. And this strange behaviour in firmness is demonstrating that. In saying that, preconditioned fruit had lower firmness, which means that they were ripening a little bit more properly than fast cooled fruit. But still, the cultivar, the variety, has limited storage potential, so not even preconditioning can improve its quality because it just can't store for that longer period. This is what this is telling us. And if we look at what happened with Polar Queen, this is chilling injury after 5 weeks at 2 degrees on the left, and then 5 weeks at 2 degrees and ripening for 3 days. And as you can see, it's not what we want to see. Very high levels of flesh browning and mealiness, particularly after ripening, regardless of the preconditioning treatment. But in saying that, even in this picture, you can see the 2 degree preconditioning treatment, the fruit among that treatment, the severity of the browning appears to be higher than the 18 degree fruit and even the 12 degree fruit. And we can show that in some tables. Again, looks complicated, the figure, but not really. So you start from a storage period of 0 weeks, 1 week, 2 weeks, 3 weeks, 4 weeks, and 5 weeks. I want you to focus on the first 3 weeks, so the left side of the figure. This is flesh browning incidence. And yes, flesh browning incidence was high, even within the first 3 weeks of storage. But as you can see, the preconditioning treatment, particularly the 18-degree one, did reduce the incidence of flesh browning. If we focus in on the 2-week storage period, 3 and 5 days of ripening, you've got 50% incidence in the 2-degree preconditioning treatment, 45 in the 12, and only 5 in the 18 degrees. And then if we go to 5 days of ripening, there's no flesh browning incidence in the preconditioned fruit at 18 degrees compared to very high levels in the other preconditioning treatments. So again, it does show that preconditioning works, except beyond 2 to 3 weeks, this cultivar just hasn't got the storage potential. So you get very high levels, very high incidence of flesh browning. If you look at severity, how severe the flesh browning was, well, it was much more severe than the Majestic Pearl. But again, within the first 2 to 3 weeks, preconditioning reduced the level, the degree of the severity of flesh browning relative to the standard cooling at 2 degrees. Beyond, in week 4 and 5, it did reduce it, but it's still very high, considering that a severity score of above 2, 2.5 is basically means the fruit is unmarketable in terms of consumer eating. You wouldn't be able to market that fruit. So it just demonstrates that the variety does have a major impact on storage potential, obviously, and whether preconditioning is beneficial or not. But in both varieties, we do see a benefit in one form or another. Okay, so finishing off the results before we go to commercial implementation. Hopefully you agree, or you may have questions, but you agree that the data suggests that preconditioning does work. So preconditioning at 12 and 18 degrees reduces storage disorders compared to immediate cooling at 2 degrees, which is our current standard practice. And this is among fruit of similar harvest maturity. So we removed any effective differences in harvest maturity, so which made it easy to demonstrate that there is an effect, it's there, and we showed it. 18 degrees, a preconditioning treatment at 18 degrees was marginally more effective than 12 degrees, but both preconditioning treatments were more effective and significantly more effective than just standard cooling down to 2 degrees after harvest. Variety, as we know, is still the limiting factor for cool storage potential. So you can apply these treatments, you can do all sorts of things, but if the variety isn't up to extended storage period, there's very little you can do. So other factors may impact on the size of the preconditioning effect, how well preconditioning works. And that could be orchard climate prior to harvest and during fruit growth. Whether you harvest unripe fruit, where it can be a tendency for export that we harvest a little bit unripe, that could impact on how preconditioning affects storage disorder risk. So there are other factors we need to look at. All right, there's only, I think, 3 slides left, and we're going to talk about commercial implementation. Right, so the issue with what we do in Australia is that it's a little bit different anecdotally from what occurs overseas, our competitors. Because of the large throughput and volumes, I mean, my understanding is that they don't cool their fruit directly after harvest, immediately cool to 2 degrees, because they're moving the fruit so quickly that they actually harvest and pack and then cool. So in a way, they're unintentionally preconditioning the fruit. Whereas we are harvesting, fruit that's 25 to 35 degrees Celsius, or let's say under 20 to 30 degrees, maybe 35 is a bit extreme, bringing it in and then fast cooling down to 1 degree Celsius. And as we've shown, the data shows it's probably not the best practice. So what I've drawn up here is a bit of a process for how a grower can potentially implement delayed cooling or preconditioning. So if we start at the top, we harvest the fruit at the right maturity, at commercial maturity, not earlier. We cool the fruit to 12 to 18 degrees. Let's say 12 degrees as a realistic temperature for commercial use. We cool it in fruit bins down to 12 and then leave it at that temperature for 48 hours. So the combined cooling and treatment time is 48 hours maximum. Then we can do 2 things. We can immediately pack the fruit, or we can, as in some cases, growers will delay the packing, leave the fruit in the bins and put it back in the cool room. So then we go through the process. Once this preconditioning treatment's completed, then if you immediately pack, you grade, pack and palletize, then place the fruit on pallets, the packed fruit at 2 degrees and cool it down to your 1 to 2 degrees, which is a normal practice. And then you store the fruit until it gets transported for domestic market or export. On the other hand, if you want to delay packing and keep the fruit in your bins, which happens, I can imagine, quite a bit if you've got high volumes coming in and you haven't got the market for the fruit yet, then you'd cool the fruit down to 1 to 2 degrees in the bins, again, standard practice. Then store the fruit in the bins, and then you want to minimize the storage period in those bins at 0 to 2 degrees, and then you'd grade and pack in a similar manner. So the process is simple. All you're doing is adding a preconditioning treatment before the packing or the cooling part of the process. The other thing I've added, which is a green arrow, is after immediately packing the fruit, you might actually, if you're confident and want to take a risk, you may not cool the fruit at all. You might actually transport it to the freight forwarder for air freight at 8 to 10 degrees, fumigate the fruit at 18, and then the freight forwarder cools it down to 2. And what that process is doing is you're actually avoiding cooling the fruit and warming the fruit up again through that kill zone. Now, I'm not suggesting that we try to implement this straight away, because you have to have a lot of confidence in your transporter and in the whole process. But when you think about cooling fruit down to 0 to 2 degrees for air freight, and then that fruit warming up at the freight forwarder to 18 for fumigation, and the issue with fruit condensation, moisture on the fruit surface, and the issues that can cause during fumigation, well, that potentially in the future could be a path you could take if you can do things very quickly within 60 hours, get the fruit to the freight forwarder. I'm talking about very integrated post-harvest processes, packing, grading, packing and transport. So to summarize, I suggest implementation will involve harvest fruit to the final cooling operation, whether on packed fruit, cooling of packed fruit or cooling down to 2 degrees in bins, has to be conducted within 48 to 60 hours of harvest. And initially it may be safer to use a preconditioning temperature above 10 degrees, but don't go to 18, because commercial implementation of 18 degrees takes a little bit of skill and understanding your logistics. So 10 degrees or 12 degrees is probably safer. Ideally implement this for all chains, export or domestic. Otherwise it gets messy trying to separate fruit for domestic market and for export market. So it's much simpler to just go through the preconditioning treatment for all fruit that comes in to your shed. First in, first out, handling is a must. You precondition fruit, and that fruit has to go out first relative to other fruit that's coming in. And avoid the temptation to pick early or slightly unripe fruit to minimize the risk if you're worried about preconditioning, because then the likelihood is that you're not going to get any advantage of preconditioning because the fruit you picked is too unripe and there's going to be other issues during cool storage and ripening, that unripe fruit. So that's final slide here. So just continue on commercial implementation. A lot to take in, but as I said, this talk will be available on the HIN website. And I'm happy for anyone to ask questions after this last slide. So a few other issues to look over in terms of commercial implementation. As I said, precondition all the fruit, then cool to 1 to 2 degrees, whether you pack immediately or you leave the fruit in bulk bins for later packing. Really, if you try to implement this, the first time you actually need to monitor fruit temperature from harvest and during preconditioning, because you need to understand how uniform temperatures are among bins, even within a fruit bin during the preconditioning and cooling. How quickly is fruit cooling to that preconditioning temperature? And how does harvest temperature affect preconditioning treatment? You know, if your fruit's coming in at 35 degrees, how long is it sitting at very high temperatures before it drops down to that 12 degrees? So there's a bit of work in understanding temperature management from harvest and through that cooling process. Preconditioning and air freight, is it necessary? Well, strictly no, because I mean, you can get fruit air freighted into your importing country, say within 4 days, and then, you know, you assume that the importer will sell that fruit, market that fruit on within a week. So, you know, it's not extended storage, so it shouldn't really need preconditioning. But then again, you don't know what the importer is going to do with your fruit. They might store it for 2 or 3 weeks until they've got the right marketing window. So again, it might be worth doing, as I said, preconditioning all your fruit regardless of the market. And as I showed you, if a riskier approach is not to cool your fruit down to 2 degrees at all and get it straight to the freight forwarder to avoid this issue of fruit condensation during warming and fumigation. I am not suggesting that you implement this next season, although I've talked to a few growers and they're thinking about trying it. If you are, maybe implement on a very small scale, do some testing in your own cool rooms, precondition, then store a sample of fruit in your cool rooms for 3 or 4 weeks and then have a look. Because each grower needs to adjust their own harvest and cooling, current harvest and cooling logistics to the new logistics that include preconditioning. And one of the major issues that growers will have is a second cool room that can be dedicated to preconditioning. Many growers only have one cool room for the cooling, and so it's going to be quite difficult to implement this preconditioning step. I think that is all. Mark?
Yeah, great.
So a lot of information there, but as I said, I'm happy to take questions, or anyone can look. Once you put that on the HIN website, people can have a look at it themselves.
Thanks, John. Well, there's actually a few questions that have come through. So I'll start the first one with Noel Ainsworth. So can you track early indications of either browning or juiciness with DA meter measurements?
Well, you would track it. You have to have an understanding of how fruit ripens. So the DA or even a firmness measurement can indicate, as I showed for Polar Queen, can indicate that ripening isn't going as is abnormal, where instead of firmness or the DA value, you know, reducing down to an expected level, you know, 1.5 kilo firmness or a DA value of 0.2 that you expect to occur after ripening. If the fruit's not getting to that point, you've got to be suspicious that it's being damaged. Even if there's no flesh browning, there's abnormal ripening occurring, and you know, you might be able to, if you actually squeeze the fruit, you might be able to detect a lack of juice. But if you don't want to go through that process, I think abnormal change in firmness or increase in firmness during storage and ripening, and no drop in the DA meter value is a good sign or potential sign that something abnormal is happening. I mean, I think that's how you'd go about monitoring potential storage disorders without the flesh browning component. Yeah.
Okay, an anonymous attendee put through a question that I think you've answered. I can see the benefits of preconditioning fruit, but how can some growers do it if they only have one cool room?
Yes, and we only do the science here. We don't try. When it comes to actually infrastructure and logistics, if you believe it's really important for your operation, you may have to install another cool room. It may not need to be as large as your current cool room, but at the end of the day, if you want to implement this, the other option is to bring the fruit in and leave it in the shed. But then, the shed temperature might be 25 degrees or 30 degrees. So the preconditioning is occurring at a very high temperature. So we don't want that. So yeah, I don't see any way around it. Installing a cool room dedicated to preconditioning where fruit comes in from harvest, the room's set at 12 degrees, you leave your fruit in there for 2 days, and then you run your packing operations, or you move the fruit to your main cool room at 2 degrees, 1 to 2 degrees. So it really does require that second cool room, I hate to say. Yeah.
No.
Yep.
Another question, Michael Troutwine. I'm sorry if I didn't get that right, Michael. Troutwine, thank you. Hi, John. The DA meter reading was about 0.6 for Polar Queen compared to Majestic Pearl of 1.1. Yep. Does the DA meter reading have an impact on storage performance?
And Christine next week will talk all about harvest maturity and using the DA meter. And yes, it does. The DA reading is giving you an idea of physiological maturity. So, and at harvest, different cultivars have a different DA value at which we consider them to be a commercial maturity or onset maturity, where they're just at the point of producing ethylene, and that's for each cultivar, that's the point where we say you should be picking the fruit. But that point is measured by the DA meter. That value will vary among cultivars. So, for example, Majestic Pearl, that value is around at harvest about 1.1, 1.2 DA units, whereas for Polar Queen, it's probably about 0.8. So it does vary among cultivars, but yes, the DA meter reading will give you an idea of the storage performance, because a lower DA meter reading usually equates to riper fruits, so a shorter storage duration it would be expected as the fruit is riper at harvest. Yes. So, and Christine will cover all that next week.
Right. Another one from an anonymous attendee is, do you think we should precondition fruit for the domestic market or air freight, or is it just for sea freight?
Okay, so for domestic market, if you're a grower and are going to store your fruit, for an extended period of time, let's say over 2 weeks, and I don't know if growers do that, they might store fruit and wait for the right opportunity, market opportunity, or may not. But if you're going to store it for more than 2 weeks, precondition. For air freight, as I said, it's probably not necessary, but you don't know what's happening to your fruit once the importer receives it, and they may store the fruit for 2 or 3 weeks. You don't know. And certainly for sea freight, this is where that you could see a lot of benefit when we know that sea freight is taking well over 21 days, just a sea freight component. So anything you can do to minimise the risk of storage disorders over that long period of time, well worth doing. But in saying that, the reason I suggested that you do it for all fruit is just purely logistical, because as a grower, how do you separate at harvest? Are you going to separate fruit for your different markets? It's really hard to do. So it's just easier to just precondition everything, and then you can make marketing decisions. I mean, certainly if you know that a certain batch of fruit that you've harvested is going for air freight, you know that specifically, then you might not want to precondition. But I don't see how in the heat of the moment and over a very busy harvesting period, you're going to be able to segregate fruit at the harvest stage. I mean, most growers would harvest all the fruit, and then you might precondition it all, and then you go, right, I've got a market, export market here or domestic market, and send it off there. So it's just for simplifying the logistics that I think it's probably wise, just if you're going to implement just precondition, have a single process to precondition all the fruit that you harvest. Mark,
okay, great. Okay. Last question we've got here is from Andrew McNish. Could growers install a refrigerated container during the season to provide another cold room at the ideal temperature?
Good idea, Andrew. They could. I mean, I think you'd need, the issue is that it's about the volume of fruit coming in. So you could have refrigerated containers set at 10 to 12 degrees. It's just a matter of how many do you need and fitting those bins. Because basically we're talking about preconditioning in bins. So it's about the volume of fruit and your capacity to actually precondition that fruit coming in. That's the issue. So yeah, I mean, something where you could bring in a portable cool room of a sufficient size or something like that. They are options, yes.
Okay.
Rather than spending the money on expensive infrastructure or another cool room. Yeah, but that's again for the grower to determine if they're going to implement this.
Okay. Michael asks, is the length of preconditioning required different for each variety?
Okay, so as far as based on on past literature and past research, and that I can't see any work being done on the length of preconditioning time. I mean, 48 hours. They've tried 24, they've tried 48, and 48 seems to work better. But we don't have enough information on whether there's a varietal aspect to that. Whether you may only need 24 hours for some varieties, and some varieties you might go to 36 hours. We don't have that's part of work that we'd like to do into the future for some of our other cultivars, to look at that aspect of it. Also looking at fruit maturity and how preconditioning affects the effects of preconditioning change with commercial maturity versus slightly unripe fruit, which is likely to be harvested in some cases. So, yeah, no, we don't have that information as yet.